Vlad, Gen AI is in all the headlines. What are your thoughts on the current state of Gen AI?
I would say we're kind of in the golden age of AI generally, and there's lots of momentum on generative AI. We've now seen sort of the power of the relatively general foundation models, and we're now seeing the development of many different kinds of specialized models for different fields. I think we're going to see a lot of different types, including kind of multimodal models, right? So we've seen ones that are applied to text or video. We're definitely going to see a lot of multimodal applications as well as applications to, various sciences and technology areas. I think there's definitely, kind of a lot of hype out there and also maybe some skeptics, that are kind of looking at the costs involved, right? And sort of the balance sheets versus revenue numbers, right? Kind of during this kind of R&D phase of Gen AI, but and maybe they have some doubts about whether it'll be properly commercialized. But I really think that that's kind of, missing the forest for the trees. I think that really the key two things that need to be addressed, nevertheless, are certain aspects of compute efficiency, as well as kind of what's the proper way to commercialize these models. But I think there are really good answers to both those questions.
What do you feel is the best way to commercialize these models? Because you're right, you read all these analyst reports, you look at their capex spending that are in the tens of billions of dollars and the payback period. So, what is the best way to commercialize it?
I think that there's going to be two different types of commercialization models. There's kind of, again, the very general foundation models like LLMs, right? Or maybe say, certain types of artistic applications of generative AI. I think that, those are maybe the early movers in terms of commercialization, but they're not necessarily going to capture the most value because there's going to be a fair bit of commoditization, right? So if your kind of endpoint product is kind of close to being completed the second that you've trained a large model, and the barrier to entry is not necessarily that high, you just need a lot of data and a lot of compute. I think there will be a certain amount of commoditization that will occur. I mean, it'll lead to useful things, but there's going to be kind of a lot of competition for many different players. I think that where we're going to see a lot of really interesting commercialization that can capture a lot of value is more specialized foundation models that cater to the needs of certain specific fields and really couple with the kinds of moats that you can build in particular industries. I definitely think autonomous driving is an example of that, but there are other examples, maybe in the sciences. For example, in biology, protein folding is kind of one interesting example where just generally, if you're coupling highly specialized insights about certain industries with foundation models, I think you'll be well positioned to capture a lot of value. So I'm not saying there's kind of a right or wrong way, but that's kind of my projection for where those different approaches will go.
How are specialized foundation models developed? So, you mentioned biology on one hand and autonomous driving on the other, two completely different aspects of the equation. How are foundation models developed for those different use cases?
I think you have to start with asking sort of what's the critical problem that needs to be solved in those fields, right? Or pick, I'm not saying there's only one, but you kind of start with a very difficult technology problem and you see how some of these tools can help. So, with autonomous driving, I think the key challenges have to do with kind of addressing the tail end of corner cases and also just validation in terms of being able to certify that an autonomous driving system operates at a certain level of safety and, kind of have an interpretable a way to look at that and not just quote a number in terms of the average, safety, but in terms of interpretability across different cases. So where generative AI can really help there is through AI-based simulation, where it can really close the gap between kind of real data and simulated data. That really opens the door to a much more scalable way of not only improving the neural networks to solve the tail end of corner cases, but also creating highly diverse, very large validation sets that can allow you to validate a system much more quickly and much more efficiently, cost efficiently than you could with only leveraging a real fleet. In other domains, I mentioned biology, right? Protein folding problem is obviously a very important problem. I'm not an expert in that area. It's more of a curiosity for me, but there are data sets that have to do with all the proteins that have been structured, and you can use those data sets to actually build foundation. So you're basically, leveraging many decades of research and things that we've learned about proteins to actually build foundation models that can kind of short circuit problems, solutions to certain problems, and can lead to entirely new paradigms of development. So, I mean, yeah, again, those might look like different things, and they are different things, but I think that those are examples of, much more specialized foundation models than sort of your typical thing that I think most people are aware of, your chat GPTs and other types of general foundation models that I think will find many use cases for any given individual. But what I'm talking about are foundation models that can enable you to solve very difficult technology problems that might not otherwise be possible, that will have, a lot of downstream value to individuals, but they're not going to be things that are going to be used necessarily by kind of the average person, right? So for the average person, we'll see the value from that kind of trickling down.
How much data is needed for AI-based simulation models? Do you need to have massive amounts of data, or can you do it with limited amounts of data today?
Theoretically speaking, right, you can consider sort of what it takes for a human to learn, right, in terms of how much data we observe. So a teenager can learn how to drive within a matter of weeks, So, and if you do the math, it's not really that much data that we're exposed to in our lives. So, I mean, theoretically speaking, you don't need that much data. Now, of course, there's a sizable gap between sort of the rate of learning of the human visual cortex and today's kind of modern machine learning systems. But there's whatever that factor is. I mean, there's definitely some big factor there, but I wouldn't say that data is really the bottleneck, right? In a sense that, I mean, in terms of video data, for example, right, and text data, I mean, we have quite a lot of that, right? And there's ways to create more data using simulation. So I think that, I don't really think data per se is the bottleneck if you're taking the right approach, right? I mean, there's always going to be a spectrum of how different companies choose to attack these problems, right? There's definitely a lot of variance, right, in compute efficiency, right, or in terms of how much accuracy you get per dollar, right, per dollar spent on compute. There's a lot of variance on that. I think that's a very important thing to pay attention to, but I don't think that it's as much of a data bottleneck per se, just given the amount of data we have available to us. That's actually quite broad. So it depends on how you're attacking these problems, right? So, for example, for autonomous driving, I would say that if you're only working with driving data, you're missing out, right? You should really be working with, kind of internet scale video data at large, right? In order to learn all the different things you have to learn about, and then bring that knowledge to the autonomous driving domain. This is very similar to how humans learn how to drive. I mean, we don't learn how to drive by sitting in a car and observing, a billion miles or something, right? Like, obviously, we're leveraging a lot of other experience.
Where are the bottlenecks? Where do you see those bottlenecks currently?
There are kind of, I'll list out the different things that you need, right? So there's the software piece, there's the hardware piece, there's validation, and there's regulation, right? So with the kind of approach that we take at Helm.AI, and also, where you can leverage generative AI, is how to essentially build the optimal software stack quickly and efficiently for any particular hardware constraint. So I think that problem, to a large extent, we know how to solve, right? And there's a way to do that kind of unifies development from L2 through L4. Right. So we don't have to look at those two problems separately. And obviously, on the hardware side, there are certain cost considerations, right? Just how much compute can you afford to put on the car, and what kind of sensor stack can you afford to actually include as part of a package that you're selling. And once you've defined sort of the hardware for the system, that there's going to be some kind of theoretical limit for what the software can achieve on that configuration. Right. But I mean, it's a very important and difficult problem to be able to then optimally build a software stack for that configuration. And that's the problem that we're addressing at Helm. The way that the hardware will evolve is a function of those different industries, right? And in terms of validation, right, it comes down to sort of where do you get your data set from, right? Is your data set coming from a very large fleet where you're, just gathering a ton of data? I mean, that's like a pretty inefficient way to do validation, right? And that's going to be a bottleneck sort of as this engagement rates improve, right? It's going to take longer and longer to actually validate systems that way. And the other approach is via simulation. So I think that's where we're seeing quite a bit of progress with generative AI. And I think that problem will be, essentially addressed using such methods. And then lastly, there is the regulatory aspect, right? So I think the biggest hurdle is regulatory, because essentially what you're talking about is what's the proper definition of a successful product that is a fully autonomous driving system. I think, as we've seen, right, it's not a simple thing to just say something like, this system is safer than an average human driver, therefore it's a successful L4 product. I think that there's going to be, there needs to be some kind of regulatory framework for addressing those questions. And I think that, different governments across the world are taking different approaches to that. But it's incredibly important to address that, right? Because ultimately, that bar of the average human driver is actually a very low bar, right? Because that includes distracted driving, drunk driving, things that, are very problematic. And really, an autonomous driving system that you want to scale to be L4 capable should be, maybe even 100 times safer than that, right? And furthermore, it needs to be interpretable, right? We need to be able to understand, if the system made a certain decision, why did it make that decision? That's going to be pretty important for dealing with the way these systems are deployed in terms of safety. I would say the biggest bottleneck is regulatory. On the AI software side, again, I think that it's now possible to basically build optimal software for a given hardware configuration and also validate that system in a cost-efficient way.
How do you validate the decision making? Is it a process that it goes through, or what does that look like?
There's different ways of doing that. So you can look at it from the perspective of kind of modularity, right? So that's kind of one thing that can help you, right? So if you take, for example, on the extreme end, an end-to-end system, right, that goes from, let's say, the RGB data or the raw sensor data all the way to the controls of the vehicle, you're basically skipping, all the way to the decision. Those systems are, much more difficult to validate, right? Because you're basically dealing with a complete black box, right? Then there's ways to actually break up the stack into different pieces. There's your perception piece, intent prediction, path planning, and then you basically do the controls, right? So that gives you more information about what's happening in between and gives you some level of control. So you can actually take, for example, a perception stack and, map out all the semantics that you want to understand and, further validate that system to where you're very confident sort of where each piece is going to fit. And you can do that, throughout the entire stack. Now, I don't think modularity completely solves the issue, right? Because there's still AI involved in between, right? So there's going to be neural networks that are effectively making decisions maybe at a lower level in between as part of that stack. And you kind of have to get your hands on what exactly those neural networks might be thinking. So there are approaches to essentially get information about where neural networks are paying attention, right, as they're making decisions. You can actually try to engineer systems that explicitly try to tell you sort of what is the system thinking. Of course, the systems have to be themselves validated. There's a whole kind of framework for safety certification that you have to follow, and how that ties into interpretability for decision making is still, I would say, an evolving field. But in terms of generating the kind of data that you would need to validate the system, I think that's where a lot of progress is being made. And, if you can basically put a system through a very large scale simulation that puts it on all the different scenarios and sort of certify that it's able to handle all those scenarios, it gives you quite a bit more confidence in terms of the decision-making properties of that system.
What are your thoughts on Tesla's approach to cracking full self-driving?
So I think Tesla has definitely been a pioneer in sort of taking the kind of large-scale fleet approach to autonomous driving, right? So they started many years ago, right, as far back as, I don't know, 2014 or something like that, with the approach of basically, unifying their stack across their entire fleet to a fully vertically integrated approach, and betting on autonomy in a big way, putting a lot of hardware on these vehicles, sensors and compute that allow them to kind of like easily collect the data that they need from those fleets, and kind of really scaling that up. And I would say, taking all that data and then crunching it through their internal process to actually improve the machine learning models. So I think that that's an impressive setup. in that it's now a large scale fleet that functions and that kind of through that kind of feedback cycle of improvement. But it's still, a relatively brute force approach in the sense that you're basically talking about, relying critically on that fleet. And so, Elon Musk tweets about this, right? I think there was a tweet recently where he said something like the main bottleneck to improvement is actually like how long it takes to validate the improvement. So basically, as the disengagement rates improve, you need to kind of wait longer for the fleet to collect more interesting data, right, or relevant data in order to either improve or certify the system. So that's not actually a good property to have, right? Because that means essentially that your rate of development is actually going to slow down as you approach better disengagement rates. So that's basically like your classical tail end of autonomy sort of rearing its ugly head, right? And so I think that it's important to recognize that that approach has certain limitations, and that's where I think generative AI can really come and can kind of change the paradigm entirely, right? Because for Tesla, it's kind of unique in that they've really bet on this large-scale fleet approach and have been doing that for many years. So, other automakers are not positioned. If they wanted to compete with Tesla using that same approach, they're not necessarily positioned to do so because they don't necessarily have that fleet. But there's now a new paradigm in which you can attack the problem that doesn't necessarily require that very large fleet to make a lot of progress.
As Tesla slows down just because of the curve, could they enter Gen AI into that? Or are they so far down the tracks on their fleet approach that they would not be able to do that?
No, I think nothing prevents them from leveraging generative AI at all. It's more about what can everybody else do. I think that the point is that generative AI can sort of level the playing field in a certain sense, right? So if it were the case where everybody had to take the same approach as Tesla, everybody has to build this kind of fleet that is kind of unified across its stack and scale up to millions of vehicles and have this kind of continuous feedback loop, then I think Tesla is sort of like years ahead of everybody else. But the point is that in the last, I would say, 12 to 18 months, it's become clear that there is an alternative route, and it's via AI-based simulation, because you can now actually close the gap between simulation and real data. So that's a very new development, right? So simulation has always been used in various ways, but I would say it's been quite limited in its application because ultimately any simulators that we've seen before AI-based simulation were not really rooted in even training on real data, right? They were kind of just mathematical models. And essentially what that means is that there's always going to be some gap. And so from both a training perspective and a validation perspective, it had very limited value. And now all of a sudden there's this big sort of quantum jump to where, okay, so if you can actually simulate the fleet data, right? I mean, instead of having a real fleet, you have essentially a virtual fleet. That totally changes the landscape, right? That changes the game. So yeah, I mean, I don't think Tesla has any limitation in terms of what they can do with generative AI. But I think very importantly, we have to pay attention to now what everybody else is going to do.
Can Helm's AI sim platform help the traditional OEMs catch up?
Yeah, 100%. And that's exactly what we're doing. So we're basically, what we offer, right, is both the real-time full stack AI software that actually goes on the cars, right? So that includes perception, intent prediction, and path planning software that runs in real time. We also offer basically a suite of foundation models for the development and validation of autonomous driving systems. And that includes generative simulation. And the aim there is to basically close the gap between what OEMs can get from real fleet data and what they can get from AI simulated data, because there are a lot of benefits to this. For example, as I mentioned, sort of this scalability question, right? If you have a real fleet, you have this kind of exponential fall off in the occurrence of corner cases, right? So as your system improves, what becomes relevant data for that system to improve further becomes less and less frequent at an exponential rate. That means that you're effectively paying exponentially more for each new improvement. Whereas with AI-based simulation, it's effectively linear because you can focus the system always on generating the interesting cases, right? You can avoid entirely simulating boring data, right? Whereas you cannot do that in the real world. And so there's that scalability advantage. And it also comes down to kind of a time, you basically can do it in a lot shorter of a time span, right? If you need to go and validate an autonomous driving system and you have to go send cars out there for a certain period of time, it could take quite a while. Whereas with AI-based simulation, you just basically, if you have the right software, you can throw a lot of compute at it and generate the data that you need pretty quickly. So you can actually accelerate time to market substantially. It's also less liability ultimately, right? So I think putting a self-driving system on the road that isn't, that's kind of in a constant state of improvement. And, I think that there's a spectrum of risk that different companies take on that front, right? But ultimately there is the liability aspect of doing so, right? So if you can basically generate all of your important data for where your system might fail, and you can learn how to improve it, if you can do all of that in simulation, that's a substantial advantage in terms of not having to actually take any risk in deploying those fleets.
How much compute's needed to scale the Helm.AI system, or does it depend on what your customers want to do with it?
On the compute side, we have, so it's actually a very important question, right? So if you take your kind of vanilla generative AI technologies and you try to scale those up, I think a lot of people talk about scaling these systems, right? It can be definitely quite compute intensive. And, what we found is that actually by combining our unsupervised learning technology that we call deep teaching with kind of additional innovation in generative AI architectures, we're able to effectively get better scaling laws. So we can actually get more accuracy per compute dollar spent than kind of like the more typical generative AI systems. As I mentioned before, there's always going to be a spectrum of compute efficiency for all these different approaches. And, we've learned a lot from both the kind of optimizations you need to do for real-time deployment of autonomous driving systems, take those lessons to kind of scaling offline models. But beyond that, just kind of applying our technology for unsupervised learning that we've been developing for many years now, it turns out that enables us to build essentially a more capital efficient version of generative AI for autonomous driving. And not only autonomous driving, actually, I would say even for other markets as well. I think those kinds of examples are important in the sense that came from, certain specific needs, right, of the autonomous driving industry. And we're now able to leverage those to build highly compute specialized foundation models, but it could also have applications to other fields. So I do think that's like a very important question, because you have companies that are just kind of throwing quite a lot of compute at these problems, and then they're able to showcase certain capabilities. But when push comes to shove, there's going to be a commercialization question. And obviously, the more compute efficient your systems are, the better positioned you are to offer competitive pricing and also generate a better profit for yourself.
I would say you're offering a balanced approach that's grounded in economics. On the unsupervised learning lane, how did you develop that?
That's a great question. We started working on unsupervised learning very early on, back in 2016. That was really kind of one of the first questions that I asked was, what's going to be our advantage in the space, right? And kind of extrapolating out to what it's going to require to actually scale L4. It was very clear that L4 was never going to scale using supervised machine learning only. And so there was this kind of glaring open problem, right, in the space, and I think AI generally at the time, that needed to be solved. And, one of the core strengths of Helm is kind of the R&D capabilities. We kind of focused entirely just for the first 2 years on addressing that problem. And, we used various insights from research in applied mathematics and the area that I worked in previously called compressive sensing. So it was, I would say, kind of a different take on AI than I think maybe was being explored as much at the time. But it was really kind of developed fully in-house at Helm, and essentially leveraged mathematical modeling in ways that were more informative and more flexible than other competing methods. So, and we used that technology to actually build the world's first foundation model for semantic segmentation. So it's basically understanding what every pixel in an image means and actually scaling that, right? So, we trained on quite a lot of data for that time, like up to 100 million images, back in 2017 or something like that. And that's how we got very accurate perception models that were better than the state of the art, and brought those to our OEM customers, and that's how we got our foot in the door and how we scored some of the major partnerships, including the partnership with Honda. But I would say it was definitely rooted in that research background that some of us had in applied mathematics.
How does the Helm.AI system detect or approach decision making, such as a construction zone or a down tree in the road or an object, if you want to use the term edge case, that normally wouldn't be there?
So there's a number of ways. One approach is to basically have a generic obstacle detection system, right? So you can actually train a machine learning model to detect potential obstacles on the road the same way that you would train a model to detect a specific object, right? So that is a well-posed problem from a machine learning perspective. So you can actually train such systems, and they'll essentially surface for you potential obstacles. And that information can be further validated by either other sensors or generic depth machine learning systems, right? So in terms of predicting depth from vision, for example. And beyond that, I think where we're going to see things go in the medium to longer term is machine learning models that actually have a fairly comprehensive understanding of the different types of objects. So kind of an open vocabulary type of machine learning model where it actually knows all the objects that you can possibly enumerate, right? It actually can classify those and tell you that's actually a construction zone, that's a tree, that's a ladder that fell off a vehicle, et cetera. So that's definitely totally within scope, right, of machine learning models. But yeah, this is actually where generative simulation comes in very handy, right? Because those situations are just going to be extremely rare in actual fleet deployments. But the objects that we're talking about, anything that can fall on the road, even if it can be a rare thing to happen, can get plenty of data, right, about those different objects from different situations, from other types of video data. So from a simulation perspective, if you can properly leverage those data sources and simulate those scenarios in a highly realistic way, then you basically save yourself. Yeah, I mean, you get something that's much more scalable in terms of addressing those corner cases.
How do you teach the system? I know it's unsupervised, but I'm curious now. How do you teach the system to understand hand gestures if somebody's waving you or they're flagging the road to tell you to go into this lane instead of that lane?
There are a couple of ways to do that. So, for example, those hand gestures, they have some meaning in terms of how we interpret those hand gestures as a function of sort of our mental model of other humans, right? What are they seeing from their perspective? What are sort of colloquial means that we have of communicating certain things, right? So we're kind of leveraging some prior history, that shared history that two people might have. And then there's the actual environment that you're in, right? So, I mean, in terms of the environment that you're in, that's your standard sort of autonomous driving task of interpreting the environment, understanding what everything is. There's sort of, your position in that environment, your state. There's a state of the other person, let's say, right? And a machine learning model can understand both and understand the relationship between both. In terms of that, shared history of what hand gestures might mean, that's another example of where you want to learn from data sets that are not just autonomous driving data sets. You can't possibly learn about all the different hand gestures that might come up by just leveraging fleet data. I mean, you might get like some bad data there, I think. So I think like there you would want to leverage probably multimodal foundation models that understand video data, that understand actions. Maybe they have text descriptions for those actions, and you can basically figure out what associate what people are doing with what are they actually intending to communicate, right? So that's definitely a totally tractable problem. And then I think you would combine that with some amount of structured data that you might produce that's specific to your application, as well as simulations thereof. So yeah, I mean, it's a totally tractable problem to solve. I'm not trying to trivialize it, but I don't think that there's anything about that problem that cannot be approached properly from a modern AI perspective.
Helm AI is advanced. You're far down the road of what you're developing. You're developing a model that is highly scalable. I love the term you used earlier, the golden age of AI. You have a specialty in this. You have a mathematical background. You have a really great team of scientists that are working with you. You have the relationship publicly with Honda. Overall, OEM wide, when do OEMs realize that they need individuals and companies like Helm to help them achieve autonomy, because you have the specialties and expertise where they don't have it necessarily?
I think that is already happening, right? Of course, every company has its own kind of arc, right? Their own trajectory. But with the example I provided earlier, right? Back in 2017, we provided technology demonstrations to OEMs that showed clearly our advantage over other competing solutions, and that was well received, right? That got quite a lot of interest from the various automakers, and we definitely got partnerships out of that. I think that you're right that it's not as simple as, okay, if you have the best tech, therefore everyone will work with you. I think that there are other questions that come into play in terms of just how certain companies are oriented, decisions they've already made in the past, just in terms of being able to properly communicate the information, et cetera. But yeah, I mean, I think that the industry is definitely very adaptive, right? It might take, it might take a lot of time, but there's definitely a trend that I think where OEMs are leveling up substantially in their understanding of autonomous driving technology, right? So in the early days, I think there was a lot of concern from automakers that L4 was right around the corner. I mean, it's sort of both opportunity and concern, but I think it was more concern because if that's the case, then they might end up being sort of like the commoditized component of that solution. And I think it led to a lot of investments. There's just a lot of hype out there about L4 timelines that just didn't come to fruition. And I think to anybody technical, it should have been relatively clear that that was not going to come to fruition. But nevertheless, it led to all these different investments that didn't really pan out. And we've seen that play out, right? But what that's resulted in is I mean, it's an important lesson, right, for everybody in the industry, including automakers. And we're now seeing automakers essentially pivot to kind of high-end ADAS commercialization as the sweet spot of where they want to focus. And yeah, we've seen that now in many cases. And also OEMs where initially they wanted to do it fully in-house and, okay, we're going to do everything ourselves. We're going to hire all these people and deploy billions of dollars. And then years down the road, it turns out not as much progress was made as they had hoped. And there's no public statements from those OEMs that, hey, we actually need partnerships. So, I mean, look, I think that it's happening. I think that there's always some kind, it's not going to happen instantaneously, but I think it's definitely now going in the right direction. So I don't see that as nearly as much of an issue as in the past.
Do you see OEMs? You're right about the focus on the ADAS, the high-end ADAS. I think that's a mistake. I think consumers are going to want level 4, as we're going to see in certain polling data. Do they get to the point, in your opinion, where they approach Helm and your competitors and license a stack from you instead of spending the billions of dollars in-house developments? Because as you and I both know, as public reported, they've already made that decision and didn't work out well.
Yeah, absolutely. I mean, I think that OEMs will be well served by partnering externally with the right suppliers, whether it be to accelerate their time to market or just to reduce their costs, right? There's going to be some inherent R&D cost to developing these technologies. And there's also kind of the uncertainty timeline wise, right? If you're an automaker and you are trying to attack these problems, there's going to be that question mark around the timeline that, is also a big concern. So if there's an external party, right, an independent company that's already built all the critical software and can offer it to you at a better price than what you can afford to build it for yourself, it's like a win-win situation, right? So that's kind of how I see it, is that what we're trying to build is basically the best option for automakers in terms of helping them catch up to and potentially leapfrog companies like Tesla by partnering externally. I don't think that it's going to be such a binary thing where an automaker will just say, okay, we're doing everything in-house and we'll never work with anybody externally. I mean, of course, it's on us to offer them the right kind of product that provides a better option, but I think we're well on our way.
Do we ever get to a point where there's a Windows, Apple OS, Linux of autonomous driving systems?
Yeah, that's a good question. I think that maybe for certain like layers of the stack, but I don't know. But in terms of like the most differentiated aspects of it, I mean, I think every automaker will want to have obviously software differentiation, right? And so that is the key thing. So in the coming years, vehicle sales, one of the biggest factor in vehicle sales will be software differentiation. And that's also where the margins come from. So from that perspective, every automaker, I think, is incentivized to produce autonomous driving features that have certain advantages over other systems. And I do think that they're all positioned to potentially produce something like that, provided that they partner externally with the right suppliers. And so the way I think about it is we build foundation models, we build real-time software that's geared toward production, but all those things can be optimized for any particular automaker. And that's what allows them to actually get software differentiation. While I think there could be a world in which there are maybe multiple systems that are shared across different OEMs, I think there will definitely be an incentive for customization based on kind of every automaker's strategy for what kind of vehicles they want to sell to their customers.
You're seeing it today. They don't want Apple to take over the car or Android to take over the car. They're all GM's trying to develop their own system and other OEMs as well. Vlad, over the next decade, how do you see the autonomous vehicle market evolving?
I think that there's going to be kind of like some continued consolidation, right? Where, I mean, we already saw a pretty extensive period of consolidation, but I think there's going to be a bit more. I think there's still, like, I think that companies that went after kind of pure play L4 are going to have a very difficult time staying independent. So I think that, that's definitely an area we're going to see consolidation. We're already seeing this kind of pivot to a more ADAS-centric approach from the automakers. Definitely an AI-first strategy makes the most sense. I think that is now very clear. So in a lot of ways, I think that, what's happened in the last 10 years is you can basically see it as like a reset in some ways, right? I think what happens in the next 10 years is far more relevant than what happened in the last 10 years. And yeah, I think we're going to see substantial commercialization of high-end ADAS software as automakers try to catch up to and potentially surpass Tesla. We're going to see an evolution of these autonomous driving systems where they go from more like autopilot type systems to L4 capable autopilot systems, and then actually truly L4 systems, right? So, and that's really more of a product question than a technology question in some sense. I think that technologically, we're going to see continued improvement of autonomous driving software to where, it certainly will go beyond sort of being safer than the average human driver and all that. But from a product perspective, there has to be a lot of clarity about what it means to actually offer an L4 product. I think we're going to see quite a bit of acceleration in the development of these systems and the validation of these systems using developments in AI, such as generative simulation. And yeah, I mean, I think that, essentially the future is bright when it comes to autonomous driving and also adjacent areas in robotics.
You're taking the tagline away from me. The future is bright. The future is autonomous. What role do you want Helm.AI to play in that market?
So, I mean, this has been the goal from the very beginning. We've structured the entire strategy around this goal. We want to be an independent company, a truly independent company that builds and supplies all the critical AI software required for scalable autonomous driving. And beyond that, we also want to do the same for other areas like, essentially robotics at large. And, we already have actually traction in some of these robotics markets, for example, in the mining market. But there are, of course, many other applications in both industrial and consumer robotics. So, but yeah, I think that's one important thing, though, is, yeah, I mean, as I said, it has to be an independent company, right? In the sense that that's also why we didn't go after, pure play L4. I mean, there were many other reasons, but that's another reason. And I think the industry will be well served by having an independent party that builds the critical software and can offer that software to many different OEMs, because there are advantages to that, right? From, both a kind of time to market and cost perspective. So I think that yeah, there's that kind of gap in the industry that we'd like to fill.
I like that. You have ambition to stay independent. I like that. You're going to move into robotics. You're going to stay independent. You're going to help autonomy scale. You're going to help potentially humanoid robots. Maybe I'm getting ahead of myself there. Helm has a very bright future. I'm excited to watch and see where you go, because I'm sure, I'll guarantee it, and let me go on the record and say I'm sure I'm going to be impressed. Vlad, as we look to wrap up the conversation for today, what would you like our viewers and listeners to take away with them?
What I'd like viewers to take away is that despite sort of all the different ups and downs of the autonomous driving industry that we've seen over the last 10 years. I think it's now a very important moment for the space where it's a bit of a moment of clarity. I think it's going to be maybe even surprising for people to see the amount of progress that happens in the coming years. So yeah, I guess as I said before, I think the future is bright for autonomous driving and especially generative AI applications to self-driving cars, robotics, and beyond.
Gen AI and unsupervised learning, what Helm is building, is ushering in the future of autonomy. The future is bright, the future is autonomous, the future is Helm AI. Vlad, thank you so much for coming on the road to autonomy today.
Thanks for having me.